So, so far we we spoken and we discussed about, introduction to statistics and or the introduction statistics. And we seen that, like, we've seen some kind of, subtopics under the introduction to statistics, which are like, what is statistics and descriptive statistics and inferential statistics and population and sample and what is statistics and parameter, right? And qualitative and quantitative variables and levels of measurements like nominal, ordinal, and interval and ratio. So these are the six topics which could be like, under the introduction to statistics. Then I started giving explanation regarding about it could be like, describing the data. When you try to describing your data, so you need to remember the two things. One is for a measure of central tendency, and second one is the measure of dispersion. And that one, we were done the measure of central tendency. Now we are stepping into the measure of distribution or dispersion. Clear? Okay. Now, see, when first thing you need to remember actually. So if you want to be, if you want to analyze any data set, for example, you have a data set, something like this. Okay, this is my Excel data or CSV data, whatever it is. You have some kind of data in a format of tabular form, right? So when we have a data in a tabular format, then, and you can simply say it's a data set. So my intuition is that I want to go for analyze this specific data set. I want to be go for analyze this specific data set. If you want to analyze this data set, and you need to remember, you have to, you need to know that what is the and where your central value is there, and you need to know that the central value. Okay, that it could be the first point. And the second one is how the data it was spread. Let me take it. I'm just taking one particular example. So this is my data set and this is my data. And for example, price variable. Okay. So I have a data something like this. So, and if you plot this one, if you plot, a scatter plot, then the data, it could be distributed something like this, right? Okay. The data, it could be distributed something like this. See, what you can do actually, if you want to be analyze this specific set of data, and you need to find the central point. You need to find the central point and how the data it was spread, that we need to go for analyze it. Okay. So for better understanding, and I would like to go for give you live example. Give me a minute. So I'm opening that one. I can share with you. Once I done, once I open that file, I can share with you guys. Don't worry. New share. And yeah. So guys, now you can see my Excel file, right? Yes or no? If you're able to see that, Excel file, you can say yes actually. If you're not able to see anything, then you can say no.
Yeah, we can see.
What you can able to see from my screen.
Yeah, we can see airlines, date of journey, source, destination, route,
Yeah, yes,
departure
Excel,
time,
right?
arrival time.
Yeah, okay, fine.
Yes, yes.
See, here I have a data, it's my price. Now I want to go for analyze this particular price variable. Okay. Simply, you can select this one. And here we have, insert and charts are there, right? And if you go for scatter plot, and you can see this is this is my price variable and it was distributed something like this. Okay. See, this is the distribution. And if you want to analyze this particular distribution, you need to know what is the mean value and how this particular data, it was spread. Okay. So two things we need to remember. One is central point. Second one is how the data, it was spread around this center. Okay. For that one, we can use the central tendency. For that one, we can use the Measure of central. Okay. For that one, we need to go for understanding the is a measure of distribution. Okay. When we are talking about measure of distribution or measure of dispersion, and the first thing is that the first parameter is range. Okay. So we would like to go for understanding the measure of dispersion. Yeah. Side heading, measure of dispersion. When we are talking about measure of dispersion, okay, so the first thing is that a range. The first parameter or the first statistic under the measure of dispersion is range. So what is the range? So range means the difference between the largest and the smallest value, the maximum element minus minimum element from the data. Okay. So that we are calling it, say, a range. Let me have a small example. I have the age data. So this is my age variable. So the age variable, it could have some kind of data, 50, 60, and 80, and 90, and 100. Okay. So within this one, what is the smallest value and what is the maximum element from this age variable? So here the max is 100 and the minimum element is 50, right? So that the 100 minus 50, it's a 50 actually. The range it was, 50. Okay, clear, right? That exactly the range variable or range parameter. Any question regarding about range? Hmm? Any question regarding
No,
about
no
range?
question.
Okay. So the second type of parameter is interquartile range, IQR. It's a very, very important parameter actually in under the statistics. Okay. So if you want to understood this, what exactly this interquartile range, okay. See, first thing is that what the data set we have it, that entire data, for example, if we have the 1 lakh of records, okay, if we have the 1 lakh of records, even if we have the 1 lakh of records, this entire thing we have to describe in a 5 elements. We have to describe in 5 elements. So that kind of thing we are calling it, say, 5 summary data. What it is? 5 summary data. So what the data we have it, that entire data, the population data, we have to represent it in 5 elements. Okay. The first element is minimum element. The second element is max element. The middle element, we can call it as the median element. Okay. So you can say that it's a 0 percentile of the data. Okay. It's a 50 percentile of the data in terms of percentile. Okay. This is 100 percentile of the data. Okay. So middle two things are like, it's a 25% of the data and 75% of the data. Okay. When you're talking in a percentile, it's a 0 percentile, 25 percentile, 50 percentile, 75 percentile, and 100 percentile. Okay. But when talking about, quartile, then it could be Q0, this is Q1, this is Q2, this is Q3, and this is Q4, like quantile, like quantile 0, quantile 1, quantile 2, quantile 3, quantile 4. Okay. So I can tell you what is, finding the minimum value, finding the max value, finding the median. It's a simple thing. The reason is that, if we have functions, we have direct functions are there. If you give that, max of data, then you can get the max data. If you go ahead with the min of data, you will get the min data, right? If I go ahead with median function, then you can find the median value, right? Okay. But the thing is that finding the Q1 and Q2, it's like 25% of the data and 75% of the data. If you able to find this data, then you can easily find the IQR. IQR means interquartile range, the difference between the third quartile minus first quartile. So Q3 minus Q1, the difference between the Q3 minus Q1, that we are calling it say interquartile range. Is it clear? Is it clear or not?
Uh,
So don't
Arjun,
worry. Yeah,
can
one
you
more time I
repeat
can,
again?
yes, I can try to explain one more time. IQR definition is Q3 minus Q1. What is Q1 and what is Q3? I can explain you clearly. Okay. See, usually you have some data set, right? Okay. Maybe the data set, it could have the thousands of observations. You can say that thousands of samples, whatever it is. Okay. So this thousands of samples, we have to represent it in 5 elements. You have to represent it in 5 elements. That kind of concept we are calling it, say, 5 summary data. What it is? 5 summary data. Okay. So the first element, so if we have the 1,000 elements, for describing the 1,000 elements, it's impossible, right? Go on each and every element, right? So that even you have the 1,000 elements, even you have the 1 lakh of elements, okay? Even you have the 2 lakh elements, it doesn't matter. Okay. Simple thing is that no, that entire data we have to represent it in 5 elements. That 5 elements names are Q0, Q1, Q2, Q3, sorry, Q3 and Q4. Okay. We have the 5 elements. So the entire data we have to represent it in 5 elements, that we are calling it say 5 summary data. Okay. So the names of that 5 elements are Q0, Q1, Q2, Q3 and Q4. Now you're thinking, what is Q0? What is Q1? What is Q2, Q3, right? It's a very simple thing. Q0 means, so from this particular data, the smallest element. The smallest element we are calling it say Q0. Okay. And from this particular data, you could find the maximum element, largest element, that we are calling it say, okay, that we are calling it say Q4. What is Q2? Q2 means the median value, 50 percentile of the data, median. Okay. So this Q1 and Q3 is, so from this particular data, so 20 percentile. So what the data which is have below the 25 percentile of the data, that no, that line we are calling it say 20 Q2. And from this particular data, what data we have it less than the 70 percentile of the data. So that line, that border we are calling it say, the border number we are calling it say Q3. Okay. This is 25 percentile of the data and this is 75 percentile of the data. So this is the way we can represent the, even we have the large data set, we can represent it in a 5 elements. Okay. Q0, Q1, Q2, Q3, Q4. Kind of concept we are calling it saying 5 summary data. When it comes to the IQR, IQR means it's interquartile range. The difference between the Q3 minus Q1, that we are calling it say IQR. Interquartile range. Now you clear, right?
Yeah. So any range they will split into 5 categories. That
Yeah.
will do
Any range.
percentage.
Even the data, it could be anything, but we have to go for represented in 5 elements. Okay. Now let's take some example. Let's take some example. I have data, something like this. Okay. So statology also you have that example. Go on to read that one. For example, if you have a data, this you have this data. Just write, I'm writing this data so that you can easily understand. Okay. This is my original data. Okay. So 92 and 88. Okay. 84 and 88 and 98 and 88 and 82 and so on. Okay. and so on. We have the 85. This is my data. Okay. See, the first step is that this is the data. What we can do, we have to arrange how we can find the IQR by handy. I'm telling actually. Okay. We have to go for arranging the data in order format. Once if you are arranging the data in order format, so you have the entire data something like this. For example, if you have the 100 elements, then you have the 100 elements here. Okay, you have the 100 elements. The first thing is that it's the smallest element, and last one it could be like largest element. Okay, so in the middle exactly your median data, right? Okay, so from this entire data, we have to represent it with some element. We have to find these elements: smallest element, largest element, middle element, and 25 percentile of the data, and 70 percentile of the data. So this is the 5 elements we have to pick up from your data. Okay, clear?
Yeah, clear now. Yeah.
Okay, just a minute. Now, let me share my screen. Let me share my another screen. Okay, so how you would like to go for? Mhm. Okay, now, okay, now I'm talking about fries. Okay, so how many records we have it? Almost we have the 10,684 records. You have it, right? Out of this 600, 6,000, sorry, 10,650 records, I want to find the 5 elements. Okay, what are the 5 elements I wanted? I want to find the Q0,
First element,
and I
last
want to
one,
find the Q1, and I want to find the Q2, and I want to find the
three,
Q3, and I want to
before.
find the Q4. Okay, so Q0 means it's a smallest element. It's a smallest element, and Q2 in the sense it's your median element. Okay, and so Q4 means it's your largest element,
Yes,
right? Okay, or else maximum element,
yeah, measurement.
large, largest element. Okay, so this Q0, Q1 means it's a 25 percentile of the data. So what data which is less than the 25%, that borderline we are calling it say Q1. What data we have less than the 70 percentile of the data, the borderline we are border number we are calling it say, okay, Q3.
Mm.
So for finding the smallest element, then we can use the min function, right? So min of, so min of, and we just give you the data, okay, and enter. So this is my smallest number. And what is your largest number? For finding the largest number, we can use the function is
Max of,
max, okay. And what could be the median value?
yeah, average.
It's not average. Average is mean, okay. Median is your,
Oh, sorry, median. Sorry, it's a median, right? Yeah, middle value. Yeah,
okay,
median of.
yeah, median of your data set. Okay, so this is your
Yeah,
median. Okay, now I want to find the this Q1 and I want to find the this Q3.
Q3.
So for
Mm.
finding the Q3, Q1 and Q2, then we have a function is quartile. What is the function it is? Quartile.
Mm. Okay.
Okay, so quartile, and you can provide that the data set, comma. The second
Yeah.
argument is that, and I want to find the quartile of 1. Okay, quartile of 1. So
Mm.
Is the element is in between the 17592 8372 or not? Quartile. Okay, I want to find the third quartile. For finding the third quartile of the price, then we can give you that, so Q3. Okay. Now you might be thinking, so is it really smallest is Q0 or not? If you want to find that, then we can have a function is, I'm just checking. Okay. I'm just checking myself whether smallest element is Q0 or not.
Then the
Hmm?
quarter one and quarter zero and quarter four, we don't have any doubt, but 25%, no, that actually
That
how it
it's
is.
it's a very
That
simple thing. It's exactly if we have the 1,000 rupees. Okay, just I'm giving an example. If you have 1,000 rupees, okay,
actually,
and
uh,
I can say that oh, uh, let me take it. You have the 10 elements. 10 people are there with you. Okay, so how many people are having the less than the 20 percentile of your amount? Okay, when you are combining the all the amount, you have there are 10 people out
mm,
there, so each one person having some specific amount, like one person having the 100 rupees, one person having the 200 rupees, one person having the 1,000 rupees, okay, one person having the 2,000 rupees, something like this. Okay, so when you're combining
yes,
that all the data, okay, so there could be some kind of percentile wise, right? So 25 percentile.
yes, yes,
So what data we have less than the 25 percentile of the data, so that number we can find it, right? Like 2,500 is your number. So who are having less than the 2,500, that means they're getting that less amount of percentage. Okay.
yes,
So I'm just giving, when you're writing an exam. Okay. So when you're writing an exam, there could be some kind of percentage you're getting. Or okay.
yes, yes, yes.
So if some people are getting less than the 25% of the data, 25% of overall marks, then they're not qualified. So how you can cut off, right? So the cutoff number, we are calling it, say, 25 percentile of cutoff, 75 percentile of the cutoff. Okay.
Yeah.
Okay. So don't worry. I can give you example. Mm, I'm copying this one. Okay. So I should go for arranging this data. No? Okay. So anyway, you don't if you're not good, if you couldn't get this 25 percentile how you're calculating. Okay. So don't worry. I can explain you one more time. Okay.
I think Anjan,
If
if you make it order by, you will get to know. I think.
yeah, yes. Order by. I'm unable to find that where I can find that order by.
Yeah,
Just
let's do one thing. Let's copy in the L column. You go to right top. There is a sort filter, no?
where it
Right
is.
corner, top right corner in the Excel sheet, top right corner.
All right.
Insert, delete. You can see. Yeah, there. Yeah, yeah. No, no. After that.
Yes. I
Editing
found it.
is there. Yeah, yeah.
Okay,
There you can
yes.
select it. Yeah.
So yes. Now I got it. Okay.
Yeah.
Expand this session. Okay. See. Oh, both are affected. Okay. Like, okay, let me take this example and sort this one. Okay, sort to smallest element. See, this is the smallest element, right? This is the element we are calling it, say, Q0. Okay?
Yeah.
Yes, let's go for the last one. So this is the element we are calling it, say, Q4. Okay? And you don't know middle value, right? Middle value in the sense here, 10684. 10684. And if you do that half, then 5342. Yes or no? 5
Yeah.
3
Yes.
50
Yeah.
5 53 5342 534. The index for the fourth, the index, what it is? 5432, right? This is the
Yes.
your
Five, four,
median.
three, two.
This is your median. Okay. And so you have the 10,684, right? 684.
Yeah. Yes. Yes.
Okay. By 2, we are getting the 5342 index. Okay. So that's the reason why I am taking the 5342 index number. The reason is that exactly the middle value. This is the one only middle value, right? Right or not? So guys,
Right. Yes. Yes. You're right.
yeah, are you following or not? I'm not sure. Okay,
Five,
so
four,
for
three,
that
two.
one,
Yeah.
I can share my screen, and I can share. I
Yeah.
can.
We are following you. Yes.
Yeah. Okay. See what I'm trying to tell you. I have the 10,000. I have the 10,684 records are there. Okay. So first thing is that I have to go for arranging the data in order format from small to large. Okay. By the time it could be like 0 index position and 10684, right? Okay, this position. So this position is your minimum value. This position is your median value. Sorry, maximum value. So how you could find the middle value? So if you start with 0 and if you end with 10684, what is the middle value? It's a 5 3
The first value plus
5
last value by
4.
2. Huh?
Yes. Yeah. Index. This is index. The
Yeah. Yeah.
position of
Understood. Yeah.
index is 0 is your smallest value. The position of index 10864, what the value we have it that we are calling its max value. The position in the value which no the position in 5342, what the value we have it that we are calling it same median. Okay. So how you could find the 20% of the data? So here we have the 0 to 10684. Then um, it's simply 10684 by 3 and 10684 by 1. Okay. 684 into, I want to find the 25 percentile, right? 25 percentile means what? 1 by 4, right? Okay,
Yes.
into
Yes.
1 by 4. What the value we will get? So calculate and tell me. 10684 1
Or otherwise, Anjan, we can take
yeah, yeah,
like
just
first value and
tell me that
median
one.
value by 2.
Yeah, tell me this one. 10684 by, okay, if you're division with 4, then what the index you will be getting? So 2 times it could be the 8. And here we have the 2 and 6. 6, 24. And how much it is?
2671. So I think 2671.
2671, right? The position what we have in 2671, that value we are calling it, say, your quartile 1. So go on to see that, the index
Okay.
position of for 2671.
2671 index value.
Yes, 2671 of index value. What is the value we have it? 5277. See,
Okay.
5277 or not?
And then still we are seeing that whiteboard. You can see your Excel sheet.
Oh, okay. Yes. See, actually, I have 10,684 and I want to find the 25 percentile of the data. 25 percentile in the sense, so 10,684 into 1 by 4, then the index is, what the index? 2671, right?
Yeah.
2671. You can clearly observe here this position. What the value we have it? 5277 or not? This value.
Yes, it's better.
5277, right? So is it
Yes.
5277?
Yeah.
Okay. And I want to find the third quartile. If you want to find the third quartile, then I want to find the third quartile. So third quartile in the sense 10684 into 1 by 3. What it is? 10684, and you have to division with 3. 3 3 just 9, okay, and 16. 3 5 just 1, sorry, 15, and remainder is 1, and 8. 8 means 6 times 18, and it could be 4 one time, right? So 3561. 3561, right? Is it correct? Mhm. Wrong. Wrong. I made the mistake. I made the mistake. Wrong calculation. So 70 percentile means what? Guys, 3 by 4, right? 75 percentile means, okay, 10 into,
I think 8013. I think,
yes.
right?
What is the value we will get? 3 by 4. It's like, 2671 into 3. Tell me. 3, 21, 26, 8, 8013. Okay, the position in 8013, what the value we have it, that particular value, we are calling it, say, over round. Okay. Now go on to see that index position, what we have it. 8013, right?
Yeah, 80.
What the value it is? 13373.
12373.
12373. Is it 1373?
Yes, correct.
12373, right? Is it correct or not?
Yeah, it's
12373.
correct only. It is
It's
the
correct.
problem only.
Okay, fine. So that way we can calculate. But for calculation of this one, you don't need to go for do this all the things manually. Okay, we have a direct formulas is there, and we can directly use that formulas. Okay, The formula is that it's a very simple thing, quartile formula. And you don't need to remember that, small, min, max also. Simply, we can go and use the quartile. Okay. So this is the formula in Excel and this formula, and you can just providing that, the data and then what the quartiles you wanted. I want to find the quartile 0. Okay. Okay. I want to find the quartile 0 and I want to find the quartile 1. So what's the formula? It's a quartile, right? Tell me, guys. You can see my screen, right? Excel or not? You can see my Excel. Can you see my Excel sheet? Hello. Can you see my Excel sheet or not?
Yes.
Okay. And I want to find the my quartile of medial value, right? So I just provide the data and quartile 2, quartile 2. Okay. And I want to find the quartile 3. And simply we can go and find the quartile 3. Okay. Then last but not least, I want to find the quartile 4. So, okay, quartile 4. So this way you can represent that, the entire data in 5 elements. Okay, the entire data we can represent it in 5 elements. Clear, right? Now, I want to go for finding the IQR. What is mean that IQR? It's a meaning of interquartile range. Interquartile range. Okay. So interquartile range. The formula for the interquartile range is it's a Q3 minus Q1. That means quartile 1, quartile 3 minus quartile 1. So simply we can go and give that, the quartile 3 is 1373 minus and quartile 1 is 5277. Okay. So you got that, 7096. So this is your interquartile range value. Okay. This is your interquartile range. Any questions? How you can calculate that interquartile range? And is there any questions? Tell me. Anyone? I'm just waiting for your confirmation. Mir Shrey. Any questions? No questions, right? Now we can go for understanding that the next
Yeah.
the next parameter from the measure of dispersion. So we can we can go for understanding the variance. So you might be thinking, sir, what is the use of interquartile range? So interquartile range could help you so many times actually. Okay. So what the data we have um outliers, when the concept comes in outlier, that time this IQR could help you a lot. Okay, that time I can explain you. And what is outlier in the sense? Outlier means there could be some kind of extreme data. So I can try to tell you that also. And we concept came right. Then how we can use this IQR, I can explain you. Okay. So there could be like whiskers. So some data we have um, Q3. Just 1 second. It's 20. Okay. Yep. See, guys, you can see my screen, right? You can see my Excel sheet or not? Now let's go for
Yes, we can
understanding
see.
that, what are the outliers? Outliers means it's some kind of extreme data. It's not bad data. Outliers means it's some kind of extreme data in your data set. Okay. That we're calling it say outliers. So how we can calculate what are the outliers are there in my data set? Okay. So see, for calculating the outlier, it could be, in a lesser, at starting points also you might have it, or else the outliers it could have at last also. I mean, mm, no, the side of biggest, I mean, larger side at the Q3 side also you might have it. So that, so I would like to go for finding the outliers. Outliers, it could be larger data. Outliers, it could be smaller data also. Okay. For calculating the outliers, we can have a formula is Q1 minus 1.5, Q1 minus 1.5 into IQR. So this is the one formula. Okay, you have to remember it. This is the lower risk curve. Okay, this is if you want to find the outliers at the smaller side. And second formula is, so I want to find the outliers at larger side. Okay, then Q3, sorry, Q3 plus 1.5 into IQR. Okay, so you know that Q1 and you know that IQR. So tell me the value of Q1 minus 1.5 into IQR. The Q1 is this one or not? Sorry, this one, right? Q1 is 5277. 5277 minus 1.5 into what is the IQR? This is the value is IQR, right? Into 7056. Okay. Q1 is H. Okay. But- And the next one is plus 1.5 into no, IQR value into IQR. See, careful observe here. Okay. The data what we have it is less than the minus 5367. Okay. Less than this value. If you see any negative value less than minus 5367, the data we are calling it saying outliers. The data what we have it more than 23,000. Okay, that data we are calling it say outliers. That means in between 23,000, in between 20 to 23,000 17 to 79,512, that whole data we are calling it say outliers. That whole data we are calling it say outliers. Is it clear my point? Is it clear or not?
Typical understanding. Yeah,
Don't know. Nothing,
it's,
nothing. So this is your data,
it's okay.
right?
Okay.
Yeah.
Yeah.
Just a minute. Mhm. lower limit. I want to find the lower limit. So this is the lower limit. If this value, lower limit, right? If the data what we have it, what we got for the lower limit, what is the lower limit here? Minus 5,367, right? So from my data set, what were the data which is less than the minus 5,367? The data we are calling it outlier. Fortunately, I don't have any kind of outliers at lower limit. Okay. When comes to the upper limit, when comes to the upper limit, okay. So Q3 plus, what is the value of Q3? 13,373 or not?
Yeah.
Okay, plus 1.5 into, this is
Yeah,
the formula. This is
10,000, right?
standard formula. This,
10,370.
yes, 7,096 into 1.5 plus 13,373. Okay, so which could we are getting the value is 23,017. Okay, greater than,
Yeah.
okay, greater than in your data set, whatever the data which is greater than 23,017, that data we are calling it's outliers. Okay, where we have it this range of data 23,017, 23,017. Okay,
Yeah.
go and see that here. Something is happened for my data. Okay,
No, Anjan, actually, you can just expand that due to width issue like that. Can you expand that? It will show about it. The size of column, you just expand it.
well, okay, cool.
You have seen hashes, right? There you just expand the size of column. You can see.
Okay, see 23,000, right? Sorry, 23 or 20,000? 23,000.
23, I think. Yeah, 20.
23,000.
Yeah, this all the
See,
data. Okay.
yeah, this all the data, it could be like outliers. So from here onwards, okay, okay. So
Okay.
this
Yeah.
entire data we are calling it outliers. Okay,
So outliers
so
will consider the negative value or the positive values.
negative values, sorry, outliers means it could be some extreme data. Sometimes some situations,
Mm-hmm.
in COVID time, the price for everything it could be high or not. Okay, some situation
Yes, sir.
the flight cost it was increased. There could be some parameter, there could be some kind of reasons why the cost of that particular the price it was increased. There could be a lot of reasons there, but what exactly this data set it is telling, there could be some kind of data, it was extreme data is there. So extreme data means because of some kind of
Mm-hmm.
seasonal thing, because of some kind of unexpected things, okay, the price it could increase. Okay, so because of that one, there could
Yes.
be we are getting that kind of larger data. So usually, the data it was starting range is 1,759 to 79,512. Right. This is very, very large, right? When you compare the small
Yes.
value, even when you
Yeah.
compare with the mean
Yes.
value, also the large value is very high, right? Okay. But the 70 percentile of the data and median value and 25 percentile of the data and smallest value, it could be some same range in the sense approximately same. Like, the difference between this smallest and 25,
Mm-hmm.
it is around 3,000. And median and 25, it is
Yes.
also around 3,000. And median also 75 also, it's around
Yes.
4,000. So the range, it could be very, it's considerable. But when you see this particular larger
Yes.
data and 75% of the data, so
Yeah.
there is lot of variation is there.
Much
Approximately,
difference.
approximately
Yeah.
80,000. Approximately 80,000. So it's a very
Yes.
large difference. Because of this large difference, if you build the linear regression, if you build any models, then you won't get good results actually. Okay, you won't get even your accuracy is very high. Your
Mm-hmm.
accuracy it could be like 95 also sometimes. But if you're depending on only accuracy, your model is 100% is suitable for anything, then it is not correct. Okay, clear? So there are some kind of
Yeah, yeah.
outliers are there. Because of these outliers, it may affect your model, results, your model fitness. Okay. So our responsibility is that we need to go for handle this kind of data also. As a data scientist, we need to talk about these outliers. If you're not considering the outliers, so you never become like a data scientist. And if you neglect these outliers, even that is also not correct. Outliers is the very important thing. Okay, we have to handle it. Don't delete it. If you delete it, then valuable information is losing or not.
Mhm. Yeah,
I
yeah.
hope
Obviously.
I hope you clear. So
Should
today
handle
I just
all the
yeah,
data. Yeah.
today I just explain only range and IQR. So the importance of the IQR, it could help you to finding the outliers and how you can calculating the outliers. So that lower less than the lower limit and greater than the upper limit. So whatever the data we have it, that particular data we are calling it say outliers. Okay.
Yeah, it's okay. Yeah.
Okay. Any questions so far? Any questions?
Yeah, no, Anjan, no.
If you want to take this screenshot, you can. Okay, guys, this is for today's session. Let's meet by tomorrow and we'll talk about the measure of dispersion. So this concepts is very, very important if you want to be analyze your data. So without these concepts, you cannot explain in a better way. Okay, bye.
Okay.
Take care. See you.
Okay, Anjan. Thank you. Bye.